Welcome back. Today we're going to be talking about solving problems involving two-step inequalities. Content objective is students will be able to solve word problems involving two-step inequalities. Language objective is students will be able to write inequalities from word problems. And why am I learning this? Well, it's important for solving real-world problems. So first, let's go over a very important table that can help us understand when we use less than, greater than, more than, or greater than or equal to, less than or equal to. So this is a chart that I'm referring to. So when we see a less than symbol, when we're talking about word problems, we might hear words such as is fewer than or is below. Now greater than, you might hear words like is more than or is above. Less than or equal to might be words such as is at most. That tends to be a very common one that students misunderstand. Also is no more than. Greater than or equal to, you might hear words like is at least or is no less than. So keep this table handy just in case you do come across some words that you're not quite sure about. Please refer back to this chart. So let's go ahead and jump into number one. It says write the following word problem as an inequality and solve. Number one says Miss Trouble charges her music students $25 per lesson plus a recital fee of $50. You pay the recital fee no matter what. How many lessons did the student take if she paid no more than $175? So first things first, let's look back at our chart. What does no more than? No more than is basically less than or equal to, meaning it can be equal to it, but it can't be more than that. So it's definitely going to be less. So it's less than or equal to. Okay, so now that we know that, let me just write it real quick. This is less than or equal to. Okay, now that we have that, I want you to understand the word problem. What are they saying? Well, it's basically saying that Miss Trouble is going to charge $25 for each lesson. So one lesson is $25, 2 lessons is $50, 3 lessons is $75. And no matter what, they're always going to get charged of a recital fee that's $50. So let me give you an example. We can guess and we can check that in one lesson, she's definitely going to pay one lesson, which was $25, and then the recital fee. So that's going to be $75. For 2 lessons, she's going to go ahead and be charging $25 for 2 lessons, which is $50, but plus that recital fee would be $100. 3 lessons, again, now it's $25 a lesson, so that's 25 times 3 lessons, plus the recital fee, that's going to be $125. 4 lessons is going to be the $25 per lesson for 4 lessons, which is $100, but plus that recital fee is going to be $150. And last but not least, just for guessing and checking, for 5 lessons, it's going to be $25 per lesson. So $25 for 5 lessons, it's $125, plus 50 is $175. So this is just me guessing and checking. Okay, from that, I do want to get that I do understand that the variable, the thing that's changing, is the number of lessons. Now, please understand, when you're looking for the variable, you're looking for something that's consistently going to change. Okay? So, now that I know that, let's go ahead and piece everything together to create an equation. Okay? So first, we do understand, since it's $25 per lesson, that is a rate, what I call a rate of change. It's changing every single lesson. It's going to change $25. So that is our variable because it's changing every single time. So I'm going to go ahead and use 25. L, the reason why I would choose L instead of X or something like that is because L is going to remind me that it's lessons. It's $25 times the amount of lessons. Now you are going to get charged a $50 recital fee every time, so we're going to add $50 to that. Now, since it's no more than, we looked at our chart earlier, and no more than, it means less than or equal to 175. So I'm going to go ahead and write less than or equal to 175. And once I have an inequality, which by the way was part of the instructions, I need to create an inequality. Here we go. The next step is to solve for it. So I'm going to treat this as if it was an equation. I'm just going to go ahead and undo addition or subtraction first, which is getting rid of this constant here, leaving me with 25L is less than or equal to 125. Now we're going to go ahead and undo multiplication or division. In this case, since it's 25 times L, I'm going to do the inverse, which is to divide both sides by 25. And that is basically to create a 1. That's what I want. So that's going to leave me with L is less than or equal to, let's see, 125 divided by 25. Can 25 go into 1? No. Can it go into 12? No. Can it go into 125? Yes, it's going to go in 5 times evenly. So basically, how many lessons did the student take if she paid no more than $175? So this means the student took less than or equal to 5 lessons. Okay, so that means she either took 5, 4, 3, 2, or 1. Now let's take a look at number 2. The instructions are the same. It says to write the following word problem as an inequality and solve. So number 2 states, Carmela wants to buy a digital camera for above $192.50. She has $24.75 and is saving $15.25 each week. In how many weeks will she have enough money saved to purchase a camera? So we need to first understand that she currently already has $24.75. That's what she has. But on top of that, she's going to be adding $15.25 every single week. So there, I'm going to go ahead and call this my rate of change. Every single week, she's adding $15.25 more. So that's going to be my coefficient, so $15.25. We're going to take this and multiply by the amount of weeks that she's saving for. So I'm going to go ahead and use W. Now, some students may choose to use X. That's perfectly fine. In fact, in your homework, most likely you will be asked to use X. But I just want you to understand that the variable is something that you can pick on your own. And I am choosing W because it's going to help me link it back to number of weeks. Now, so with every week that passes by, she's adding $15.25, so we're multiplying those two numbers together. But again, she already has $24.75, so I'm going to add that to how much she's going to have. So here, she's wanting to buy a digital camera that's going to be more above $192.50. So it's going to be more than that. So I'm going to go ahead and say it's going to have to be greater than $192.50. So notice since it's going to be above, it's not going to equal $192.50. So this would be my inequality. And now all I'm going to have to do is solve. So first we're going to undo the addition. We're going to subtract $24.75 to get rid of this constant here. That's going to leave me with $15.25. W is greater than, here, I'm going to do some side work to figure this out, $192.50 minus $24.75. We're going to have to borrow, leaving me with 5. We're going to borrow again, leaving me with 7. We're going to borrow again, and that's going to leave me with 761. So it's going to be $167.75. We're not done though. We're going to have to get rid of this coefficient here. So since it means $15.25 times W, the inverse is going to be to divide both sides by $15.25. And then we're going to get W is greater than. Once again, notice my inequality symbol did not switch. Why is that? Because I wasn't dividing both sides by a negative number. Okay, so now that I have that, let's go ahead and do some more side work to figure out what this is going to become. $167.75 divided by $15.25. We're going to first move the decimal 2 places to both the dividend and divider. 1,525 is going to go, it cannot go into 1, 16, or 167, but it can go into 1,677 once. And that's going to leave us with 1,525, which is going to go in once evenly. Perfectly. So I'm going to say that W is greater than 11. So what did W represent? W represented the number of weeks because that's what they're asking us. So I'm going to answer the question in a complete sentence. And I'm going to say it took her no more than 11 weeks. So in order for her to have enough money saved for this camera, she's going to have to save up for more than 11 weeks. So real quick, is that going to include 11 weeks? Will she have enough money? The answer is no. She'd have to save more than 11 weeks. So that's going to be 12, 13, 14, 15, etc. Number 3, it said it rained a total of at least 10 inches. The first day it rained 5/10 of an inch or half an inch. Then it rained 2/3 of an inch each day after that. For how many more days did it rain? Okay, so first, since this information was given to me first, was at least 10 inches. So at least means you can include 10, so it could equal 10, or it could be more than 10. So we're going to go ahead and use a symbol greater than or equal to 10. Now, on the first day, it rained 5/10 of an inch. Okay, then it rained 2/3 of an inch each day after that. So here, I'm going to ask myself, what was the rate of change? What was changing every single, in this case, day? I'm going to say the amount of rain that it rained each day. Since it was 2/3, I'm going to go ahead and call that my coefficient, my rate of change. So it's going to be 2/3 for every day. So I'm going to go ahead and multiply that by D for days. Now again, you can use X, but I'm picking D so it can represent days. Now, it has to also include the amount it rained the first day, which is the 1/2 inch. So I'm going to go ahead and add that. So this is going to be greater than or equal to 10. So this here is my inequality. Now, all I have to do is solve. So we're going to go ahead and undo addition or subtraction first. We're going to have to do the inverse of adding 5/10, which is to subtract 5/10. Notice I'm doing this to create a 0 because these are additive inverses, leaving me with 2/3. 2/3 D is greater than or equal to 9.5. Now here, we still need to get rid of this coefficient since it means 2/3 times D. We're going to do the inverse, which is to divide both sides by 2/3. Leaving us with D is greater than or equal to blank. Now here is where you typically get to decide, do you want to turn things both into decimals, both into fractions? What's it going to be? For this particular one, some of you may want to do decimals because that's what you're more comfortable with, but here I'm going to highly suggest you turn them both into fractions. Why? Because 2/3 is not a nice decimal. In fact, it's a repeating decimal. So for those reasons, I'm going to turn 9.5 into a fraction. So 9.5 also can look like this. So if I turn it into an improper fraction, that's going to be 18 plus 1 is 19. So it's 19 over 2. So I'm going to go ahead and do some side work and call it 19 over 2 divided by, because that's what it means, 2/3. I'm going to go ahead and rewrite it to multiply by the reciprocal. I can't cross cancel. So 19 times 3 is 57. So we're going to have 57 over 4, but we can't leave our answer like this. We can't say it's this many days. So let's go ahead and divide that. It's going to go in once. And that's going to go in twice with a remainder of 3. Sorry, not twice. Did my arithmetic wrong there. It's going to go in 4 times, which is going to be 16 with a remainder of 1. So it's going to be 14 and 1/4. But let's remember, we need to actually answer the question. We're not just going to simply say D is greater than or equal to 14 and 1/4. I would say that it rained for at least 14 and 2/4 more days. Okay, and again, this basically came from D is greater than or equal to 14 and 1/4. These are equivalent values, so they are the same. Okay, for number 4, same instructions. It says Maria is starting a small DVD business online. She makes $2.25 on each DVD she sells. To start her business, though, she had to invest $750. How many DVDs does she need to sell before she starts to make a profit? Okay, so first of all, if she's making $2.25 on each DVD, that is your rate of change. That means she's going to take $2.25 and multiply that by the amount of DVDs that she sells. So we're going to go ahead and put D, because this means $2.25 times D. If she's invested $750, if she wants to make a profit, she's got to make more than that. Okay, so notice I'm not going to include $750. Why? Because if she gets exactly $750, she's not making profit, she's breaking even. Breaking even means she spent the same amount as the amount she's getting back. So she's not gaining any profit at all. So this would be my inequality. So now what we're going to do is solve. So what do? We're going to undo this multiplication here by dividing to get rid of this coefficient. And here we're going to be left with D is greater than. Notice again the inequality did not flip because we did not divide by a negative number. So 750 divided by $2.25. We're going to move the decimal 2 places. Decimal here belongs at the end, so 2 places there. 225 can go into 750, let's say about 3 times, which is 675. So this is going to leave me with 570. Now this can go into that, let's say, also 3 times, which is 675, which is going to leave us with also 75. So let's bring down another 0. That's going to go in 3 times. And you're going to notice that this is going to repeat. So the answer is D is going to be greater than 333.3 repeating, or it's the same as 333 and 1/3. So what does that mean? You can't sell 1/3 of a DVD. So should we round this down to 333 or round it up to 334? Basically, you should be rounding up, because if you round down, she's not making enough money to actually get a profit. So to answer the question, I would say that she needs to sell 334 DVDs or more to actually make a profit. Okay, for number 5, it says, David owns a yellow cab. The company charges a flat rate of $2.50 for each cab ride, plus 75 cents per mile. David figures he needs to average at least $12 for each cab ride to make a profit. At least how many miles must rides average to make a profit? So here, we're referring to every single cab ride. So every single cab ride, they're going to be charged $2.50 because that is the flat rate that they're charged the second they get into the cab. But then they're also charging 75 cents per mile. So what is your variable? It would be the amount of miles. So we're going to go ahead and take the 75 cents that people are going to be charged for every mile. So we're going to multiply that by M for miles. But then on top of that, again, they're being charged this flat rate of $2.50. So if he wants to average at least $12, that means it's going to be greater than or equal to 12, because at least will also include the value. So this would be my inequality. I'm going to go ahead and start by undoing the addition to get rid of this constant here, leaving me with 75 cents M is greater than or equal to, that's going to be about $9.50. Now we're going to have to get rid of this coefficient by undoing multiplication. So we're going to go ahead and do the inverse, which is to divide both sides by 75 cents. Notice here the inequality symbol is not going to flip because we did divide both sides by a positive number. So we're just going to simply divide 950 by 75 cents. This is going to move the decimal twice, move the twice here as well then. 75 can go into 95 once with a remainder of 20, bring down the 0. 75 is going to go into 200. Let's see if I think 3 would be too much, so I'm going to go ahead and go for 2, which is going to be 150. It's going to give me a remainder of 50, bring down the 0. And actually, let me go backwards. Instead of going in for decimals, why don't I turn it into a fraction? Because that might be easier. My remainder is 50 and my denominator is 75. This is going to reduce to basically 12 because I can divide by 25 and 2/3. So now to answer the question, how many miles must he drive to make a profit? Well, I would say he'd have to at least drive 12 2/3 miles or more. Okay, so notice here I don't have to round it because miles can be in fractions and decimal values. Now, in the last one, you couldn't really sell 1/3 of a DVD, and that's why we had to round it up. Okay, we're on our last problem. It says here, Catherine is 5 years old and is so excited to ride all the rides at the local amusement park. Unfortunately, she is 42 and 5/10 inches tall, or 42.5 inches tall. And one ride requires that she be at least 50 inches. You want to tell her about how many years she will be able to ride. A quick Google search shows that the average child grows 2.5 inches per year. How many years will you tell Catherine it will be until she can ride all the rides? So, first of all, you need to consider that she has to at least be 50 inches. That means she has to be greater than or equal to 50 inches. Okay, well, she's already currently 42.5 inches tall, so we have to consider that as her height. If Google is claiming that she's going to grow 2.5 inches each year, we're going to go ahead and consider that our rate of change. That's going to be what we're going to use for our variable. So it's going to be 2.5 for each year, so we're going to multiply that by y, and then we can go ahead and add that to her original height right now. Okay, so this here was our constant, this here was our coefficient, because this is what's going to be changing the amount of height every single year. So here's our inequality. We're going to go ahead and solve by first getting rid of the constant by undoing addition. And now that's going to leave me with 2.5y is greater than or equal to, that's going to be about 7.5. Now all we have to do is divide both sides by 2.5 to try to create a 1 using the multiplicative inverse. And y is going to be greater than or equal to, and again, the signs didn't switch because we were dividing both sides by a positive number. Here, this would be fine if you wanted to turn it into a decimal because 1/2 is a nice decimal, but I personally like to work with fractions, so I'm going to go ahead and turn this to 7.5, which is going to become, let's see, 14, 15, 15 halves, divided by, here it's going to be 2 times 2 is 4, plus 1 is 5, 5 halves, which is going to become the multiplication of the reciprocal. I can cross-reduce. I can cross-reduce here as well, leaving me with 3. So according to the Google search, it's going to take her at least 3 years, which means 3 years or more, and Catherine will be able to ride on all the rides that she wants. Okay, so thank you so much. That actually concludes the lesson for today. And as always, until next time, bye.